We will be now doing the lab 5. This lab is about the longitudinal modes in a laser beam. This corresponds to module 1.6. One of the important aspects of a laser is that the photons are bounced back and forth between two mirrors, which means that these photons bounce back and forth between two points which can act as reflectors. Because these reflect between these mirrors and also they have slightly different frequencies, you have a number of standing waves set up in between the mirrors. This particular property is only true for laser light. For an ordinary light, an incandescent bulb or even a fluorescent bulb, this does not apply. So the longitudinal mode and the transverse mode are a particular characteristic of only laser beams. These modes, longitudinal modes, in this particular lab we are not talking about the transverse mode, which also play an important role. We are going to talk about the longitudinal modes only. There will be a number of modes inside this laser beam. Because the beam width itself is so small and there will be hundreds of such modes, experimentally, though you can demonstrate it, you require much more sophisticated experiment to demonstrate these longitudinal modes, which perhaps you will do when you go to higher power lasers. But as an introduction, what we will be doing is we'll imitate these longitudinal modes, which are waves bound between two points, which is mirrors in the case of lasers, and in this case a reflector and a vibrating string. So in reality, what we are going to show is the vibrations of a vibrating string, which is not identical to the longitudinal modes inside a laser, but that gives an idea of what these longitudinal modes are. One important thing one has to remember is that the longitudinal modes, the larger the number of longitudinal modes that are there, then these will compete with each other for the energy. So the total energy of the beam itself will be very, very small. So it's essential to reduce the number of longitudinal modes inside the laser beam. So in order to do that, of course, there are other ways of doing it, what's called mode locking and so on and so forth. But in today's lab, what we will be doing is we'll imitate the longitudinal modes by showing the vibrating string experiment. So when we now go to the first slide, you can easily see longitudinal modes are an important aspect of laser beams, and in the experiment which we will be doing, we'll be having a vibrator which can vibrate both in a transverse mode as well as a longitudinal mode. They can vibrate both ways, and we can connect a string, long string, to that. In order to provide this string to vibrate, we have put a certain amount of mass to it, the mass times acceleration due to gravity. This gives a tension to the string. And then we have a frequency generator. These I'll be showing you in a few minutes in the experimental setup. This vibrator can be provided with any frequency we like with this frequency generator. By adjusting the frequency of the frequency generator, we can produce several harmonics. Let me first explain what a harmonic is. If the string vibrates in a single loop, it simply means that the total length of the string is only vibrating in half wavelength of the frequency. If it is vibrating in two loops, which we call it a second harmonic, then this will be vibrating with the string length equal to the wavelength itself, and so on. So therefore, by changing the frequency and by changing the tension or the length, any of these things, we can produce any number of harmonics. Inside the laser beam, we have such standing waves. So therefore, we will be performing this experiment such that we will be actually creating number of loops by changing the frequency, and from the frequency we can actually calculate any of the parameters we like. For example, the equation now shows that the n is the number of loops which we will be showing. We can vary the number of loops, varying the number of the harmonic, and then we can change the length of the string, that is from the vibrator to the pulley, we can do that, or we can change the tension, which is the weight we put for the string, such that we can put more weight, you can have more tension, and this mu, which is the so-called linear density or the mass per unit length, usually we do not change for a given string, because the string has certain length and you divide that by the mass, that will simply gives you mass per unit length. That's called a linear density. So in this experiment, what we can do, we can put a given frequency and then keep the tension constant, M over L constant, L constant. Therefore, by changing the frequency, we can get different number of loops. So we will demonstrate, a large number of such vibrating frequencies, and we will put them in a table wherein we will both vibrate it in the longitudinal mode as well as transverse mode. In both cases, we can experimentally determine the frequency, and we can read off the frequency from the frequency counter. So we will start beginning showing the experiment itself.